Hi everybody, welcome to another video in Trigonometry, section 4.1, graphs of circular function. So graph of the trigonometric function. And then you may ask, we have a calculator, why don't we just graph the function? Why do we have to study about it? Well, of course, by the way, if we want to graph it, for example, y equal to sine x. This is clear. Y equal to sine x. Before we graph it, make sure that it is in the radian mode, because for the circular function we define that as a circular function defined the trig function on the arc length. So hit mode and make sure that it is in the radian, and then we have the graph. Yeah, so the sine graph of sine is like that. So what's the big deal of it? Of course, then yeah, so the graph of sine x look like that, but we have to worry a lot more about all of those other characteristics that might come from this graph. For example, does that look like it is repeating, right? And what would be the maximum or the minimum values? Where is that equal to 0? And in general, how the graph will look like. Right, so those are a lot of things that we study about the graph of the function sine or the trig function in general. But again, if you want to graph, make sure in the radian mode. But this section, we do most of the graph by hand. Right, so a few characteristics of trigonometric function or circular function. All of the trig function have the first part, which is called the periodic function. So circular function is a subset of something bigger. It's called a periodic function. So what it means for some function to be periodic. So a function is said to be periodic if there is a positive number p such that every x in the domain we have f of x plus p equal to f of x, meaning that the y values will repeat itself after a period p. So let's look at the graph again. So the y values will repeat itself after a constant p called the period. So the smallest values p, if there's any, such that f of x plus p is equal to f of x, is called the period of the function. So the periods of the function is where the function repeats itself, and the period is not the smallest number that the function repeated itself after that period. Right. So of course, circular function, so we define based on the unit circle radius of 1. Right. So think about this. We define, let's just write sine. By the way, let's use theta. Sine is equal to the y values, cosine is the x values, and tangent is y over x. Now let's first focus on the sine and cosine for a moment. The x values, let's say we are at this point. If we go around a circle, go around it, and we get back to this point, it has the same x values, right? So if we go one extra revolution, it will get back to the same x values. And then we said, yes, that obviously is true. If we go one extra revolution, we'll get back to the same point, the same x values, the same y values, therefore the same sine values, the same cosine values, if we go one extra revolution. Right, and then you say, wait a minute. If we are at this point and we have these x values, then that means we also have this point that have the same x values too, right? And that would be true. Yes, those 2 points have the same x values. And we go about this much of a circle, right? We get back the same x values. But that is not a period. Remember, the period have to be constant, and that will be a lot more different x values. For example, if the x values is here, which is equal to 0, we only need to go half a circle to get the same x values. Of course, that distance we have to go around to get back to the same x is different than this distance to go around to get back to the same x, right? So because those numbers are not the same, it cannot be the period. A period is, it will be the same, doesn't matter where we are on the function. So if we're here and we go one complete revolution, we get back to the same point. So one revolution. If we go here, one complete revolution, get us back to the same point. So because of that, the period of sine and cosine is 2 pi. Right. Now, so the period of sine and cosine is 2 pi on one revolution. Consequently, reciprocal of sine is cosecant and reciprocal of cosine is secant. So sine, cosine, cosecant, secant, those functions, the period is 2 pi. So how about tangent and cotangent? Now, on section 3.3, we define the tangent to be the tangent. We draw the tangent to the x-axis, and whenever we have an angle, we extend the terminal rate intersect here, so this will be tangent of theta. This values here. If this is the unit circle, tangent is whatever it is on the tangent axis to the unit circle will give us the tangent values. Now, so that point has that tangent values. Now, if we go the opposite direction, will be at this point. It's if you extend the terminal rate, it still got the same point. So either this point and this point have the same tangent values because it is on the same line that intersect the tangent axis. So those 2 points have the same tangent values. And so rather than go one complete revolution, this is only half a revolution. So if tangent, the period is half a revolution or 1 pi, cotangent is reciprocal of that, is also pi. So put all of them together, we say for every real number t, sine of t plus 2 pi is equal to sine t, because 2 pi is 1 revolution. Adding 2 pi to it, we get back to the same point. Therefore, the same x values, the same y values, the same sine values, and the same cosine values. So, we just need to keep this in mind. Sine and cosine function are periodic with period equal to 2 pi. Yeah. So, we have here every number t, the function cosecant, secant are periodic, period 2 pi, and sine, cosine, by that I mean sine t and cosine t are periodic with the period of 2 pi. So I will write periods of sine t, cosine t, reciprocal of sine is cosecant, reciprocal of cosine is secant, and the period of those are 2 pi. Because when we go one complete revolution, we get back to the same x, y values, the same sine and cosine values. And we did show that the period of tangent and cotangent are pi. Keep that in mind. So, what is the significance of that? The significance of this is because the y value will repeat itself within a period. I mean, after it go one period. So in that case, if we want to graph it, we only need to graph one period, and then the graph will repeat itself every period after that. And so that's exactly what we'll graph. Just need to graph one period, and then copy and paste that part of the graph throughout. Right. So all of the trig function, all of the circular function have the properties that all of them are periodic, and this function have the period of 2 pi. This function have the period of a pi. Right. Now let's first look at the graph of y equal to sine x. Now this is where the confusing comes in. We say x cosine is equal to x values and sine is equal to y values, and then we say y equal to sine x. So is that x is the cosine values? Yeah, actually it's not. The way we graph this, the unit circle and the graph is different things. Once again, the graph is not the same as the unit circle. In the unit circle, we have x-axis and the y-axis like this. Yes, but in the graph of the periodic function, we have the x-axis and the y-axis. But that gives us x, in this case, is the angle, and it is not, or either the angle or the arc length. X here is not the cosine values. So, right. So x here is the angle, or we call here t. But because when usually we graph, we have x-axis, horizontal axis, y-axis is the vertical axis. So usually we have x and y. But in this case, x is the angle and y is the values of the trig function. Right, so back to the unit circle, this one. Y equal to sine x. If x is the angle, sine x equal to y is the values of the trig function. Right, now think about this. If we look at the angle here, doesn't matter what the angle is, doesn't matter what theta is, we have the point on the unit circle that has the y values. So there's always the y values regardless of where the angle is, right? Because of that, doesn't matter what the angle is, we always have the y values. Therefore, we always have the sine values regardless of whatever the angle is. So in this case, the domain, and we will write all real numbers. Because doesn't matter what the angle is, there's always an x and the y values, and the y values is the sine of that angle. So there's always the sine values. Therefore, the angle can be anything. All real numbers we can write in the interval notation, negative infinity to infinity. So negative infinity to infinity, and that's all of them. Right, so that is the domain. All the possible values for x, or all the possible values for the angle. All real numbers. Right, the range. The range is actually the trig values, trigonometric function values for that particular angle. Now, in the unit circle, sine is equal to the y values. Now, if it is on the unit circle, the y values can be anywhere from -1 to 1, but it cannot be more than 1 because it has to be within the unit circle, right? The y values, when it go around, it's only changed from -1 to 1. It only changed from -1 to 1. So the range, we say sine of x have to be between 1 and -1. Or we write the range be from -1 to 1, including the 1. It has the equal sign, so we use the bracket between -1 to 1. So that is the range. doesn't matter what the angle is, the y values on the unit circle can only be from -1 to 1 inclusively. So the range from -1 to 1. The period, we already know that, 2 pi, right? The period is equal to 2 pi. That's what we know. Now how about zeros? Where the function equal to 0. Now look at the unit circle. Sine, once again, is the y values. Where on the unit circle the y values equal to 0? Well, it's going to be here and here, right? Here and here. So 0 is, I'm going to draw the unit circle here. And 0, this where the y equal to 0, right? So sine x equal to 0 when x equal to, could be 0, could be pi, or could be 2 pi, or could be -pi, right? So on those values, y equal to 0, sine equal to 0. So we write sine equal to 0 at these values. So if we have sine equal to 0, we say x is equal to k pi, where k can be all the integers -1, 0, and 1, and so on. So those are the zeros. Alright. And then a few things that we need to know. So with this, let's put on together in the graph. First, the range is between -1 and 1. So the y values is between -1 and 1. So let's, the scale, I'm not going to focus on that. Let's say 1, 2, 3, 4. Let's say this is -1. And 1, 2, 3, 4. Let's say this is 1. The range from -1 to 1. So the graph of sine has to be between -1 and 1. So the graph of the function sine between -1 and 1. So the graph has to be within this. Right. Also, the function equal to 0 when we have a multiple of pi. So the way we say k pi, or we say it, this is a multiple of pi. So meaning that 0, the function will equal to 0. Let's say 1, 2, 3, 4, 5, 6, 7, 8. Let's choose 8 to be 2 pi. So 4 of them is pi. So because later on we might have to subdivide them. So let's just go pi, 2 pi, and then 1, 2, 3, 4, that would be 3 pi. The opposite direction, 1, 2, 3, 4, that -pi. 1, 2, 3, 4, -2 pi. 1, 2, 3, 4, -3 pi. Because we might have to divide smaller, so we choose 1 tick to be, 4 tick to be a pi, and 4 tick to be 1, if we have to divide them later. Right, we know for sure those are the values where the function equal to 0. So the graph will get back, we have this point on the graph. And then next, let's look at the unit circle once again. It starts out at this point where the y value is equal to 0. When it goes to pi over 2, which is this point, is where pi over 2, the y value is equal to 1. So when it goes to pi over 2, which is half of this, it will be 1. And when it go to pi, it's back to 0. And when it go to negative 3 pi over 2, the y value is equal to -1. So between 0 and pi, the maximum is in the middle. The minimum is in the middle, pi to 2 pi. So put them together, we have the graph of the sine function. If we have to draw this by hand, that is the graph of the sine x in one period. Like that. Now, in one period is like that, meaning if we have to draw the whole graph, just copy and paste. So I will copy this windows and paste for every 2 period, every 2 pi a period. So in particular, I'm just going to copy this into these windows. So we start from 0, maximum, 0, minimum, and back to 0. So even though I'm not draw very well, but with all of the details in here, make the graph look actually a lot better. And then of course we copy and paste, but this only have the second half, so it will be just this, and this is the first half. So when we graph the sine function, focus on one period, and then we just copy and paste each period throughout the whole graph. And be mindful to this information. Domain on real numbers, range from -1 to 1, the period 2 pi, and then we have the graph. Now the most important about when we graph this is the pattern of the sine function. Doesn't matter the period and the maximum, minimum, it doesn't matter what it is, but it will be like this: 0 max, 0 min, back to 0. Or we say the middle max, middle, min, back to the middle. So the pattern of that is the middle to the max, back to the middle, to the min, and then go up to the middle again. For one period, it will repeat this pattern. And so that's how we can graph the graph of y equal to sine x. Of course, in the next 2 sections, we focus more than just sine x. What happened? We have sine of 5x or 5 sine x. Like we study about the graph of sine of 5x, something like that, or y equal to -2 cosine x with the numbers in front. So, but for now, just the basic, just a function itself. And so for sine, all real numbers is the domain, range from -1 to 1, and the zeros, multiple pi, and the pattern is this. Right. Now let's go to cosine of x. Now, cosine of x in the unit circle, that is the x values. Now one thing similar to the sine function, doesn't matter what the angle is. A point on the unit circle will have x values, we have the cosine values. So clearly we have the cosine values. The domain once again is all real numbers. So it could be anywhere on this number line, or we say -infinity to infinity. And then the range, also similar to the sine function, because it is in the unit circle, the x values can only be from -1 to 1. So we say -1 less than or equal to cosine less than or equal to 1. So meaning that it can go from -1 to 1. Because doesn't matter what the point is on the unit circle, the x values can only be between -1 to 1, and the cosine can only be between -1 to 1. That's why we write like that. And the period, we talk about this, the period is equal to 2 pi. Right? So exactly the same as the sine function, those three things. The difference is the zeros, where the function equal to zeros. So I will have the unit circle here. Where x equal to 0 will be this point and this point. So we can say 0 is when x equal to maybe pi over 2, maybe -pi over 2, 3 pi over 2, those values. So in general, we can say x equal to pi over 2 plus k pi, where k can be any integers. Yeah, so we can pi over 2, and then we can add a half revolution to get to this point or get back to that. So the zeros are those values. And now with that we can put together the graph. Again, between -1 and 1, 1, 2, 3, 4 tick. The graph of cosine will be between these two dashed lines. Right. And then let's say it'll be pi, 2 pi, 3 pi, 0, -pi, 1, 2, 3, 4, -2 pi, -3 pi. Right, and we know that the 0 is equal to pi over 2, which is halfway point, and you can add a pi to it, so we add the distance of a pi to it, so pi over 2, or 3 pi over 2, where the cosine equal to 0, maybe 5 pi over 2 or -pi over 2. So those are the values where cosine equal to 0. Now, back to the unit circle. We know the graph will go through those points. This point. When the angle equal to 0, we have this point. The x values of that point is 1. So we start out from 1 and go to this point. So we kind of have the idea that it will go down, touching this point, go to the minimum, and then back to that, and then back to the maximum. So this is the graph of one period. So if we want to graph y equal to cosine of x, what we graph is one period, the pattern of y equal to cosine x, we start from maximum back to the middle to the minimum to the middle and then max. So this is one period of cosine. And once we have one period of cosine, we can copy and paste this throughout the whole number line, and we have the graph of y equal to cosine of x. Maximum, middle, yeah, those are the pattern, but we have to be very careful. We have to write down what is a period. A period is 2 pi, right? So we have to have a period. So that is one period. This is one period. So within one period, we have the maximum, middle, minimum, middle, and max. So one period. Hold like that, and I'll just copy and paste throughout the number line. So this is the graph of y equal to cosine of x, and this is the pattern. So the only thing that's different between the sine and cosine, actually a few things that different from sine and cosine. Of course, the pattern itself and the zero. The period will be the same, domain will be the same, the range will be the same. The only difference is the zeros, where the cosine equal to 0 is different than where the sine equal to 0, and the pattern will be different. Right. Now the graph of tangent of x. Always, once again, refer back to the unit circle. It's that, but notice a little bit different than when the graph of tangent of x is actually, we have to draw the tangent axis, and with an angle we will extend the terminal ray, intercept the tangent axis, wherever it intersect will give us the tangent values. Right. So let's just go over all of this. What will be the domain? Right. And then before we do anything, nice properties is that, the identity tangent is equal to sine over cosine. So that's the first thing we'll notice, because now we know the graph of sine, graph of cosine. We can start with that. So to go with the domain. So what is the domain? If tangent is equal to sine over cosine, the domain, if it is a fraction, if it is a ratio, the denominator cannot equal to 0, because divided by 0 is undefined. Because of that, the domain is where the cosine of x not equal to 0, meaning that this is where cosine equal to 0, meaning we do not have any of these values. So we say x not equal to pi over 2 plus k pi, where k I can write like this, or I can say just integers, or I can write from -1, dot 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 -1 0 1 2 3 4 and or -2 -1 0. Okay, I can list them or just say integers, right? Because I cannot divide by 0, that's why the tangent x, the cosine cannot equal to 0, so it cannot be these values. So if we have to draw it out, we cannot have these values or these values. The range. Well, if you look at this, if we have a very bigger angle, it will intercept, pretty much it will intercept the whole tangent line. So because since it can be anywhere on this line, it can be any numbers. So the range for the tangent is all real numbers. because we have a tangent axis and it could be anything. So all real numbers, so we write negative infinity to infinity. And the period, we already talked about that. Period for tangent is equal to pi. The zeros, the tangent is sine over cosine. If the top is equal to 0 and the bottom is not, it is equal to 0. So the 0 is where the sine equal to 0. And that is the multiple pi. So the 0 is these values. And finally, for tangent, cotangent, secant, cosecant, we also have the asymptote. It's where the function undefined. Where is undefined, and that is where the cosine equal to 0, meaning that it is pi over 2 plus k pi, where k's are integers. Right, so those are the properties of the tangent function. Right, first of all, where it is equal to 0, by the way, let's just put some numbers on the axis. So since the period is a pi, if I choose a pi like this, so it's too small, so let's make it like 6. Take it as a pi. So 1, 2, 3, 1, 2, 3, so 6. Every 6 unit is a pi. So, and then 6 unit is 2 pi. So nice thing about this is we can choose the axis we want to. Negative pi. We can choose the scale as we want to. If we want to graph like that, we worry about the graph in a little bit. But those are what the values we have. Right. So those are the values. Now, look at the zeros. The zeros, try to see what color should I use. Right, zeros is x equal to k pi. So we meaning the function we have. We go to this point. Next, the vertical asymptotes, where the function undefined. The function is defined everywhere except for pi over 2. So for pi over 2, or 3 pi over 2, the function is undefined. So I'm going to draw the vertical asymptote. The vertical asymptote is not part of the graph, but we have to draw it so we can see. By the way, we only worry about one period, which is a pi. But we have the asymptotes here. And then the function, all we know is it starts from 0. Now, according to this, it starts from 0, and then when the angle gets bigger and bigger, extend the terminal rate, the tangent gets bigger and bigger. So when we go in that direction, it gets bigger and bigger, so it's approaching to the asymptote. So the asymptote meaning that the graph will get close to it, but will never touch. Get closer and closer to it, but never touch. So if that is the positive sign, the negative sign, if you extend the terminal rate, it will be negative. So on this side we have negative. Right? So this is a pattern of that. And so this is one period. I will just copy and paste. Just copy and paste for all the period, and each period is between the asymptotes. Of course, you can also say that a period of tangent may be, so that is one period is the pi, right? So just copy and paste that part. Yeah, so this is one period. One period. You see the graph's still the same, right? Yeah. Right. So the thing that I noticed in the pattern of tangent is that this tangent is increasing. Just will be easier if we just remember that. So pattern of y equal to tangent x. Just one word, increasing. Yeah. So we know there's a bunch of asymptotes for the tangent. There will be a bunch of asymptotes. A period, of course, is between the asymptotes. A period is from an asymptote to an asymptote, and 0 will be right in the middle. So just increasing. So we have to go from the minimum or from the negative infinity to infinity. So that's why we have the graph of tangent. Right. So each one of them has distinct characteristic: sine, cosine, and then tangent. Now if you want to graph tangent, and then of course it looks like that. Now if you want to look exactly like this, we have to change the windows. Hit windows, we only go from negative 2 pi to 2 pi. And how did we divide this? From 0 to pi, we divide to 6. So the scale is pi divided by 6. The y values doesn't matter. Now the graph will look more like what we have here. Right. So if we want to graph, the graph to look nice, like what we have on the paper, what we have on the calculator, change the windows. But first, have to be in the radian mode. That's the most important. The graph has to be in radian mode, and then we can choose the period, so that when we put in the windows, it will graph nicely like that. If we want to get back to the original or the standard window, hit zoom number 6. That gets us back to the standard windows. If we want to specific windows, hit windows and then change the x and the y values. I mean change the windows from the minimum x to the maximum x, minimum y to maximum y. Right, so those are the graphs of sine, cosine, tangent. Of course there's still 3 more functions, right? Now before we go to that, just go over a few things. So even and odd function, again, just the basic properties. Later on we'll study a little more of this. Even function. So the even function is where f of negative x is equal to x. The odd function is where f of negative x equals negative f of x. That's nice and all, but in terms of the trig function, they can only be either even or odd. And an even function, if it is symmetric on the y-axis, now that's what we worry about this, because we study about the graph now, right? So symmetric on the y-axis is even. An odd function is symmetric on the origin. So if we have the graph of the sine x, it is symmetric on the origin, right? And the cosine is symmetric on the y-axis. As you see, this is the mirror image from the left side and the right side. You cannot do that with the sine. If you flip on the other side, it will not be the same graph. But the cosine, if we flip it, it will be the same graph. Tangent, because it goes to this point, it is symmetric on the line y, symmetric on the origin. So in this case, sine, cosecant, tangent, and cotangent are odd. Cosine and secant are even. So cosine and secant are even. Everything else is odd. Cosine and secant are even. Everything else is odd. Right. Now we focus on the graph of cosecant of x. Right. Graph of cosecant of x. The domain, similar to what we have for the tangent. Cosecant, we have to write 1 over sine, right? Right. Okay. The domain, because we have the ratio, domain cannot be equal to 0. So the domain is whatever the values is, but it cannot be, sine x cannot be equal to 0. Otherwise, divide by 0 are defined. So the domain is on the unit circle. We cannot have these values that where sine equal to 0. So we can say x not equal to k pi, where k's are integers, because those values give us cosine, give us sine equal to 0, and divide by 0 is undefined, and we cannot have that. We cannot have that. The range. Now a little more difficult. How did we define secant based on the unit circle? So again, on the unit circle, we have the tangent axis. If we want tangent, we extend the terminal rate and intersect on the tangent axis. This distance is tangent of theta. And the secant will be this values. And because that will be outside of the circle always, whatever point on this line connect to the origin have to be more than 1. By the way, this is secant. We focus on cotangent. Similarly though, I'm going to draw the cotangent axis. Extend the terminal rate. This distance is cotangent of theta. This one is. And cosecant is this one. Once again, this is outside. That is outside of a circle, so it has to be more than 1. Or it can be this side as well. Could be less than -1. So the range for secant, for cosecant is outside of 1. So I will say cosecant of x is greater than or equal to 1, or cosecant of x less than or equal to -1. It's completely different than sine, cosine. Sine, cosine between -1 and 1, and cosecant and secant are outside of 1. Think about this. If we have 1 divided by, if we put any number that is between -1 and 1, like if you put 0.2 in here, we have a bigger number than 5, right? Bigger number than 1. If put negative here, it will be less than -1. Because we put at the denominator sine, and sine between -1 and 1. If we divide that by the number only between -1 and 1, the result have to be outside of -1 and 1. So the range will be on the left of -1, on the right side 1. So that is the range. The period, we talk about this, This is similar to sine, cosine. The period is 2 pi. And the asymptote will be similar to what we have earlier. The asymptote is where the function is undefined. The asymptote, vertical asymptote, where the function is undefined. That means where the sine equal to 0. Meaning that where we have sine equal to pi, 2 pi, or in general equal to k pi. Right. Okay. And the pattern, that will be very, very easy. When we try to graph the cosecant or secant, first we will graph the reciprocal function. So the first thing I do, I will graph the y equal to sine x. This is the y equal to sine x. This is not part of the graph. So just draw in the dashed line. This is y equal to the reciprocal function sine x. And we know sine x, it is between -1 and 1, right? And also we know that there's a vertical asymptote at multiple pi. Or easier, the asymptote is where sine equal to 0. This is sine x, it is equal to 0 here, 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 and here. Or we can say 0, pi, 2 pi. Those are the values that make sine equal to 0. Right? Those are the intercepts. And so we have the vertical asymptotes there. Vertical asymptotes, so we draw a dashed line. Because the y-axis so those are the asymptotes. Now, what the graph of the cosecant will look like. One thing we know that is that if sine is positive, 1 over sine is positive. If sine is negative, 1 over sine is negative. And the graph have to be outside of -1 and 1. So, if this is the graph of sine in the middle, where it's equal to 1, 1 over -1 is still -1, 1 over 1 is still 1. So the graph of cosecant will be starting from the maximum and minimum. It just bounces off and approaching to the asymptotes. So that's why we have to draw the reciprocal function first, and then we just bounce off the maximum and the minimum. So that is the graph of cosecant. If we want to graph, it has to be 1 over sine x. We cannot enter cosecant, so we enter 1 over cosecant. And then let's change the windows from, let's say, -2 pi to 2 pi. And one take, let's say, about pi over 2. So you see, we have those graphs. Right? So that is cosecant of x. Now once we have that, the secant will be very easy, be very similar to it. Secant is 1 over cosine and the domain is where the denominator not equal to 0. Meaning that x not equal to pi over 2 plus k pi. The period we already have 2 pi. Yeah, tangent and cotangent, the period is a pi. Everything else is 2 pi. Right. The range, similar to what we have earlier. The secant, the distance is going to be greater than 1 because that is the point outside of the unit circle. So it is secant is greater than equal to 1 or less than equal to negative 1. Or if we write that in interval notation, I didn't do that earlier. Negative infinity to negative 1, including 1, union. So this is union. So all mean all 1 to infinity. Negative infinity to negative 1, union with 1 to infinity. Union all means all. Mean either on this one or on that one. The vertical asymptote, where the function is defined, it cannot be the asymptotes. The vertical asymptote is where the function is undefined. Meaning that where x equal to pi over 2 plus k pi. But in terms of graphs, the graph of cosine is bounded from negative 1 to 1. Don't worry, I will change that in the note before I post it. So first, we have to draw the graph of cosine, which is bound between negative 1 and 1. Yeah, I just copy and paste and forgot to change. That's a terrible mistake. Sorry about that. Right. Because when I draw it, it actually turned out to be the same thing, which is impossible. Right, cosine. For the graph cosine, let's split that into 4 equal pieces. And each window is 1 period. Period is cosine is 2 pi. Right. And the graph of cosine starts from maximum, middle, minimum, middle, max. So this is the graph of cosine. And copy and paste for 1 period. Right, so this is the graph of y equal to cosine of x. And then whenever it is equal to 0, we have the asymptotes. Yeah, we change that when I upload the note. Right. And the graph will bounce up the maximum and approaching to the asymptotes. So those are the graph of cosecant x. Yeah, not that. Right. Once again, in the note when I post online, I will change this to cosine of x, and then so you don't have to have the same problem. Right. Next, y equal to cotangent of x. Cotangent is cosine over sine. Now the graph of this, I will do similar to what I did in the tangent of x. Just want to maybe just staple this. Okay, so it's not moving, not going anywhere. Yeah, so it should be that. Once again, sorry about that. Right, the domain. If the function is cosine divided by sine x, the denominator cannot equal to 0. Meaning that it cannot be equal to 0. The range, similar to the tangent axis, could be anywhere cotangent axis, so it could be anywhere on the cotangent axis. So the range will be on real numbers. Period, we already talked about this. A pi. Zeros. 0 is where the top equal to 0, where cosine equal to 0. Which means here and here. And the asymptotes is opposite, I should say complement, is different than what it is in the domain, meaning that the denominator is equal to 0, so where the function is undefined is where the asymptote is. Yeah. Meaning that where the function is undefined, where the denominator equal to 0, meaning it is a multiple of pi. Right, so put together in the graph, it is a period is the pi, so we let's just say we take is a pi. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Right, where it is equal to 0. Oh, pi over 2. Okay, pi will be between here, here, and here. here between a pi, and where it is equal to k pi or multiple pi, the function is undefined, but we have the asymptotes where the function is undefined. Of course, not including the y-axis. Yeah, I should make the scale a little bigger than this, but it doesn't matter. And then 0 will be in the middle. And the characteristic to this is, let's start here. Originally, if the angle is small, the cotangent is very big. When the angle is about that much, it's getting closer to 0. So the characteristic of cotangent is that it is decreasing. Sorry. So 0 or the middle, and then it will be decreasing. So cotangent x is decreasing. So when we graph tangent or cotangent, have to write that as a ratio. Where the top equal to 0, we have 0. I mean, where the function equal to 0, where the bottom equal to 0, the function is undefined, but we have the asymptote at those points. So once again, this are the graph on the trig function. Again, I will upload the correct part of the graph here, so sorry about that. And then pretty much that's all we have for this section. So just the basic. In order to graph the function, we have to know the domain and range, the period. 0 is where the function equal to 0, or the asymptotes if there's any, and just keep in mind the pattern of sine, pattern of cosine. Tangent is increasing, cotangent is decreasing. And then in order to graph secant or cosecant, just have to graph the, this is sine, this is secant, sorry. Just have to graph the reciprocal function. Graph sine, cosine first, and then whenever it is equal to 0, there's the asymptotes. Wherever the sine or cosine equal to 0, we have the asymptotes. And then it just bouncing off the maximum and the minimum. So those are the graphs of the trigonometric function. Right. In the next section, the next two sections, we'll worry about the more variety of this trig function. But this section just the basic of the graph of the circular function. As always, thank you for watching. See you in another video in trigonometry.